Well, hello, everyone. Super jazzed about this assignment and about the topic of ANI and AGI loops today. Thinking, and to set up some context here for you before we get started, thinking under the lens of that I already am an expert in these topics and how I would be making that case to my colleagues or to industry pros if I were to be that expert. So welcome to my brain. Welcome to the beginning of our semester journey, where I'm going to tie two lifelong passions, including nuclear power and water reclamation, to a new obsession, which is data center optimization. Today, I'm going to map out tools, systems, and how we'll judge success. And I'm really excited because you'll notice that on this journey, we're going to continue to remind ourselves of how ANI plays in, how AGI plays in, and what the governance is that we're going to need to continue to optimize both. So first, close your eyes for a second, dream, maybe open them up now, dream big, and dream bigger. Here we go. So as human beings, we learn by trying, we learn by checking, and we learn by fixing things. Not by prophecy, as I said on the slide here, not by guessing. I'm going to define a couple of these terms for us here for operational standpoints. So AGI, I'm speaking about broad adaptable capability. So not just the human intelligence part of it, but also the ability for this to create capacity for us, as you'll see in a moment. From an ANI standpoint, I'm talking about tools. I'm talking about narrow, specific tools that produce specific outputs. And then just to link it in, generative AI, thinking about that statistical next token prediction. We're going to ground ourselves in the process of planning, acting, observing, and then revising. And really our goal throughout this entire process is going to be how transparent are we and how do we optimize transparency instead of having to search for answers. And so from this beginning, we're going to say that this is all AGI adjacent, meaning this is the governance or the rules that are going to enable us to scale from ANI to AGI. So everybody has to make choices, right? And choices can hurt, help us, or be neutral. And we need models that can explain the data behind the choices that we are making. Especially when we think about high stakes situations, we need our data and our models to be highly interpretable and also to be highly transparent. Why it matters is that at this point, audits and that transparency, you'll hear me hammer that home over and over and over again. All of that counts. We must have that, especially when we're talking about nuclear power, when we're talking about water reclamation, when we're talking about how that feeds into AI and data centers. We cannot just rely on, oh, trust me, or it's going to be okay, or we think this is fine. We must have that transparency and that data to back it up. So in this instance, again, this is where AGI adjacencies come in, the governance and the rules that are going to let us scale to get us this feedback loop that we'll continue on in just a moment. So first, let's talk about gates. When I talk about gates throughout the presentation, I'm talking about measures or how we are measuring certain standards. So first, we need to do what we're calling the shadow mode, right? We want to make sure that we're testing behind the scenes. We want to make sure that things are optimized, they're working correctly, we're really comfortable with everything, and that we've built that trust with people before we actually get out and do a pilot into the real world that could actually potentially impact people's lives. So what we'll look at agreement rates with humans, and we are going to break down each of these segments in just a moment. We're looking at how often are we overriding things and why we're having to override them. Again, why is the AI causing us to have to do that? We're looking at the uncertainty. How confident are we in what AI is producing, whether it's ANI that's producing a specific output, whether it is when we finally get to AGI where it's optimizing loops and it's self-serving and self-optimizing. Are we confident, and what is our level of confidence in that? And then also, how often are we having to rework something downstream? So I'm going to introduce KPIs that are truly illustrative at this point because we have no baselines for what I'm talking about yet. But if we did, we would be setting specific targets, and I've just put some here for you. So we would be looking for higher agreement rates. These are the points. We're looking at having lower and continuing to lower those overrides. We're looking at what is our uncertainty and how quickly are we able to overcome that by our second cycle, because you'll see that second cycle is going to come in through each of our different components. And then again, how are we reducing the rework? So from a conceptual standpoint, again, this is AI enabling. We have many tools, we have many gates, measures feeding into one master system. All right, we're in business school. What's the ROI? What are we going to be making off of it? So here we're leading with math, we're leading with data. Again, we're leading with transparency. We're not leading with our feelings and our hopes. Hope is not a business strategy. What we're looking at here again is the hypothetical, the baseline and the waterfall getting us to our net impact. So we start with our baseline like we talked about. We have our gates or our measures that have their individual ROI components that we're tracking that then feed into the overall impact. Why this is important, we're trying to maximize the level of transparency here because again, when we're talking about nuclear power, people are going to get really nervous about this unless there's measured controls and obvious data that we can back it up with. And so we need to be able to segment that, because if there is even just one segment of these metrics that isn't working, that also is going to drive individual go or no goes, and if we are able to scale and continue. So the biggest roadblock here for ROI to us would be if we aren't able to segment this overall ROI and actually be able to report individually. And if we end up with blended averages or something that's very ambiguous and hard to explain. Again, this is AGI adjacent, meaning that we have proper guardrails and rules that are going to enable us to scale. So I've kind of hinted at loops here. ANI is driving one specific purpose and outcome. Once it gets us to the AGI, we're actually talking about these feedback loops and these process loops. And I'm thinking about this like help a brother out. We have power, we have water, we have data. They're all going to have to work better together, and they're all going to be feeding into each other. And we know from life that we're only as good as our weakest link. So we need to be able to trace where the data center is going to be producing heat. How is that flowing, as you'll see soon, into meaningful ways that we're going to impact different areas of water? How are we able to move and transport that water back to our power sites and using that to make sure that we're controlling the nuclear? And then are we optimizing the output of that nuclear to make sure that we have enough power to get into that data center? So again, we're looking for measured improvements across the loop. Roadblocks here, quite obvious, would be, do we have weak cause and effect? We have to be able to back up all of our claims with data. So here, from an AI perspective, this is AGI enabling. Again, we have many tools feeding into our one system. This closed loop is the system, and this theme will come up consistently throughout the rest of our presentation. All right, I've hinted at it. I'm excited about it. Hold on to your seats for nuclear fusion. It's just the same power that's being produced in the sun. How do we harness that here on Earth? Because we are going to need massive outputs of power to be able to fund what we are doing here. So we talk about nuclear fusion heat as firm if it is consistently put out. And what we're looking for here is that we have to have our shadow work done, as I mentioned before. We got to do all of our optimizations and our simulations behind the scenes to get us to that first gate test, to get us through each of the different gates that would get us to our actual pilot. But we must do all this stuff and have high levels of certainty and confidence before anybody is going to let us be putting reactors or anything else up on in their backyard. So why this matters, though, we have to get to high output, consistent, firm heat in order to fuel the rest of the loop, as we'll see in just a moment. And those firm heat hours are what show our value in the model. The roadblock here is, again, if this is the weakest link, the whole thing fails. So from an AI perspective, we're looking at ANI here for one tool to perform that one job of making sure that we've identified the heat risks and also the nuclear risk that we need to mitigate. So once we have our nuclear process solidified, site is going to be very important because, again, who's going to want this in their backyard? So what we're looking for here is what we're calling grid headroom. So do we have an area that actually has infrastructure already, and also areas that we could expand that infrastructure and rapidly expand it? Also areas that would be close to where the heat and water can be used. So from that triangle, we're looking for where could we put a nuclear site near a data center, near where there is water that is easily transported. And what we're looking at to drive there is what we're calling HVDC, which you can think of as the efficient long distance power lines, or how current and that energy is moved around. Because ultimately we're going to be producing massive amounts of nuclear power. We have to have the infrastructure in place or the capacity to build it in order to move that power around and do with it what we actually need it to do, which is fuel our data centers. What we're looking for here and why it matters, we're looking for the interconnectedness, the timing here again, because that's going to determine our overall speed. And the biggest roadblock here is if we have any breakdowns in the system, the delays are actually our mitigating factor and will determine our speed. So as you can see, again, from an AI perspective, this is AGI enabling. We have many tools feeding into our one closed system. All right, fabric. Why are we talking about fabric? Especially when it comes to data centers. So first, you can think of the fabric as our scorecard. So managing data centers, we have what we call service level objectives, and water, you'll see, is going to be the coefficient to all of these different processes. So our scorecard is on the right here. We have PUE, WUE, ERE. You can think of these as power, water, and energy, and how effectively they are running through our systems and our reuse, ultimately leading us to optimized uptime, which is our goal for ROI. So what we like about this real-time scorecard is that it also helps show us the different tiles will actually show where the drift is, meaning it's very, very easy for ANI to identify for us where those gaps in our system are that we need to optimize and where we need to focus our resources and our energy first and our human capital. So why it matters, all three of these things feed into the overall uptime. And when we have good uptime, we have good ROI, and we have good money coming into the business. One of the key roadblocks here, actually, as we'll see in a moment, is this idea of the water, because we're trying to reclaim water through a new process. And that peak season water stress is really going to be a limiting factor for us. So again, thinking about how this is impacting ANI, we have one tool, we have our scorecard here with one job to deliver the optimized output for us and for us to know where we need to divert our time. So now that we have our power and our site, we have our data center all ready to be optimized, what are we going to do with all this heat that we're generating? So we want to be able to send our heat to the closest, easiest place, or the easiest sink, we call it, that it can be stored or utilized. And so on the left-hand side of the visual here, think of that before as our big data center. It's crunching stuff, it's doing stuff, it's creating massive amounts of energy and heat. You can see we're flowing most of that into our absorption chillers. We have a metric called COP, which you can think of as the efficiency of the overall ability of it to cool and to quickly cool that water down. And what we're looking to do, though, is flow it into those chillers first, which is going to help us with the nuclear. It's going to help us keep the data centers clean. But also then we're flowing additional energy depending on these sites. Maybe we're using the heat to actually help us with desalinization, helping us generate more water to get back into our system. Also, we could divert it if there is local municipality interest in it. We could divert it into these what we're calling heat pools. So we could divert the heat to actually be used for additional resources within a community should they want that. So again, we're leveraging ANI here to monitor and to use our one tool for one job, which is to optimize where the heat is headed and what it is being used for. All right, so I've talked about heat, I've talked about nuclear. Now I'm talking about my other pet project, which is water reclamation. So to ground us in managed aquifer recharge. So what we're looking for here is we've all seen over the news in the last couple of years, water's everywhere, right? We have storms coming in, we have floods happening, we have tsunami warnings, we have hurricanes and all this stuff. And I'm not going to make a claim about whether that's good or bad, or I'm indifferent. What I'm saying is that we need water in this system to enable us to get to AGI and to help us to optimize it for the future. So why don't we be good about using that water that we have? What we're looking at in the graphic here is what we call a hydrograph. So there's a maximum that we're actually looking at these different aquifers. Think of them like lagoons or swamps or various wetlands, their ability to absorb and then maximize where we are flowing that water from. There's an optimal level of where we could actually pull from these different areas And what we're going to do is want to put them into these transport systems that then we can put them into wells, we can store it, and we have the infrastructure in place to be able to move that water from where we don't want it, where it's flooding and causing harm, to where we do want it, which is to our nuclear sites, our data centers, and then back out into the community as much as we can. So we're looking at how do we move the maximum amount of water with the maximum amount of quality. And obviously, there's a lot of different things that are going to feed into that in terms of policy, as we'll come back to in a little bit. All in all, though, you can think about, again, I'm talking about many different tools feeding into our one system of getting water where it needs to go, which is AGI enabling. And once we know that we have the water and that we're confident of where it's going, how do we control it? I'm going to introduce a couple of different terms here. MPC, which is our predictive control. So you can think of that as our planner. Then you think we're going to use our plans and we're going to learn from those to improve our policy. And then always we're going to have human eyes on things, right? We want to still have that human layer to make sure that we can throw the override switch if something's happening. And the graphic here we're looking at, again, from that hydrograph curve, we know that there's an optimum level of how much water is flowing into systems and what we can pull from it. So at some point, what you see, the little yellow blip on the right there, we've gone a little too far. At some point, we would have wanted a human to intervene in that anyway, and we would have that baked into our system. Why this matters, we're calibrating things to make sure that, again, we are optimizing all the outputs, that we're also lowering how those peaks are happening in terms of water output, spillage, we're minimizing the effects of it on the environment. And one of the key roadblocks here would be the trust from the operators in our system. But ultimately, again, we have many tools feeding into this control system, enabling AGI. All right, so now that we got through all of our risk mitigation, we're onto our pilot. We want to start small in shadow mode again. We want to make sure that we're clearly reporting against our gates and our measure numbers, and those will inform whether we are going to grow or whether we're going to stop what we are doing in the actual real-time pilot. So I'm proposing here for all of you, let's just say that this is hypothetically happening in Buckeye. We're on a main corridor on the I-10. We're close to the main metro area of Phoenix. We have tons of talent coming out of ASU. We have all of our gates that we're monitoring and looking at. We've put all of the processes in place. And now we just have to make sure our metric is going to be 2 clean cycles, as I mentioned earlier. So each of these gates has to clear those 2 cycles consistently to move on. If we have 2 back-to-back misses, we would go back, we would revise, and we would start over again. What we're looking at to optimize here is that data and interconnectedness, again, that our model is flowing in our loop as optimized as possible. And here again, we're AGI adjacent. We're putting guardrails in place and rules that would help us scale our pilot. Again, hypothetical KPIs, again, we're looking at agreement rates, we're looking at overrides, we're looking at the efficiency rates, and ultimately we're trying to make sure that we have lowered our overall cost of errors to maximize our ROI to the business. So one last piece that we're going to need to protect and guard, and this is going to help us with all of the issues with everything that humans are going to be worried about here. We're going to make sure that we've practiced failure, we're keeping really good records, and that we're checking our truth and able to report on that. Why this matters, the more that we can show that we've able to pass these drills, that we know what we're doing, that we've planned for contingencies, our logs are tamper evident, we're actually being transparent with the public. We're going to get a lot more buy-in from policymakers. We're going to have a lot less to worry about in terms of feelings and I wonders and all the other things that come up with that. Again, just another layer of governance is going to be critical for the rules that are going to help us scale. So bringing things home on execution, we're only going to move forward when the numbers say that we're ready. 2 clean cycles lead us to scale. 2 misses lead us to revise. We're looking at our gates constantly, and we have our AGI adjacencies in place with the guardrails and the rules in place that are going to let us scale. So thank you so much for coming along my hypothetical journey using AI, ANI to get us to AGI, how we optimize within our loops. And for just a reality check for a couple things to take home, always thinking about which gate would fail first and what we would fix, and ultimately what pilot we would or would not execute and why. Really excited about the journey, really excited about more to come throughout this semester. And thank you so much for listening to my AGI self-sustaining loop.